In this video, we're going to look at a formula that is very important in financial mathematics. In fact, when we talk about annuities, when we talk about mortgage payments or payments on your car, this formula is going to be very useful. So what does this formula mean? Okay, and where does it come from? And how is it useful? Okay, so we'll explore a couple of those things in this video. So first of all, where does the formula come from? Now, before we say that exactly, I want to do kind of a side calculation. So let's multiply x minus 1 times 1 plus x squared plus x cubed plus x to the fourth plus x to the fifth. Let's just multiply that out. Okay, so I'm not really saying why we're doing that. We'll see in a minute here. But let's do it. How would we do this? We'd multiply this x by each of these terms here. And then we can multiply the minus 1 by each of these terms. So let's do it that way. Let's do that pattern. So x times 1 would be x. X times x is x squared. X times x squared is x cubed, and so on. And notice, when we finally multiply x times x to the fifth, we would get x to the sixth. Okay, so I just multiply x by each of those terms. Now let's multiply minus 1 by each of the terms. Minus 1 times 1 is minus 1. And we'll get minus x squared, and so forth. And the last thing we'll get is we'll have a minus 1 times x to the fifth, and so we end up with minus x to the fifth. Now, if we try to simplify this, notice we get some nice cancellation. These x and minus x cancel. Same thing with x squared and minus x squared. In fact, almost everything cancels except, let's see, we have x to the fifth cancels minus x to the fifth, except these two terms in the middle here. So what we get is that this is equal to x to the sixth minus 1. So let's rewrite what we just did. We have x minus 1 times 1 plus x squared all the way up to x to the fifth. That ended up equaling x to the sixth minus 1. Okay, so this times this is equal to x to the sixth minus 1. Okay, now let's take both sides of this equation and divide by x minus 1. Okay, notice what will happen. This x minus 1 will cancel over here. And on the left side, we just have 1 plus x squared all the way up to x to the fifth power. And it turns out it's equal to x to the sixth minus 1 over x minus 1. Okay, now notice there's nothing really special about me choosing to stop at x to the fifth. I could have stopped at x to the seventh power, let's say. So add a few more terms here. How would things have been different? Well, everything would have canceled except two terms in the middle would have been x to the eighth minus 1. So notice this number 6 is 1 bigger than that 5. Okay, so another way we could write this is we could write that if this number up here is n, okay, I had a 6 here, we could rewrite this formula as 1 plus x squared plus x cubed plus dot dot dot, and we would end at x to the n minus 1, right? Because if this is n, this would be n minus 1. This is 1 smaller than this. Okay, and that's exactly our formula here. That's exactly the formula that we have. Okay, so that kind of explains where this formula comes from. Now, how can we use it? Well, sometimes in some applications, we want to add what are called geometric series like this. Okay, we have 1 plus 2 squared plus 2 cubed plus 2 to the fourth, and so on, all the way up to 2 to the ninth power. Now, one way to do this would just be figure out what each of these expressions is. You know, 2 squared is 4, 2 cubed is 8, and so forth, and add them all up. But that's kind of a time-consuming process. And it would be really impractical if instead of stopping at 2 to the ninth, if I had stopped at maybe 2 to the 100th power. Okay, that would take a long time to add all those up. But actually, we can just use this above formula where x is equal to 2. Notice the x's would be 2. And the n, okay, what would the n be? Well, the n would be 10. Okay, because notice this is n minus 1 is 9. And so the n would have to be 10. So notice this is going to equal 2 to the 10th power minus 1 over 2 minus 1. Okay, if you look at this formula, that lines up exactly with this formula if I let n be 10 and x be 2. Now, 2 to the 10th, I believe, is 1024. And so 1024 minus 1 is 1023. 2 minus 1 is 1. So it adds up to be 1023. Okay, 1,023. So that was much quicker, I think, than if we had added all these up. Okay, and it would even be more beneficial if we'd had a longer expression, which would be take a really long time to add all these up. So this formula makes some calculations more simple. And in particular, when we talk about annuities and mortgages, this formula is going to be useful.